Hey everyone, welcome back to your math class and to lesson 13 where we're going to continue working with exponents. So up until lesson 11 we were working on algebra, obviously after our first unit, but then in the previous lesson, lesson 12, we took a little bit of a break from algebra to introduce the concept of the exponent. And in this lesson we're going to get a little bit more comfortable working with exponents. We're going to look at some more complicated problems and I'm going to solve some for you after you guys give them a go. So let's dive right in. So the plan for this lesson is we're going to quickly review what exponents are, and then we're going to jump straight into the practice problems. After that, I'm going to go over some exponent rules. So some rules that show you kind of where exponents come in handy when you're doing more complex calculations. And then we're going to jump into some practice problems involving BEDMAS. Now, I'm not going through any examples for like using the exponent rules because you guys should be comfortable enough with BEDMAS because it's not, you're dealing with addition, subtraction, multiplication, division for the most part. And the only thing that we're adding into that is the exponent rules. So what we're going to do is we're going to go over the exponent rules, and then you guys can have that in your notes in front of you while you're trying to solve the practice problems so that you can use them as kind of a little bit of a guide. So yeah, let's go into the review then. So what are exponents? Well, hopefully you'll recall from our last lesson that exponents represent repeated multiplication. So that's similar to how multiplication represents repeated addition. So, if you've got 4 times 6, let's say, that's the same thing as 4 plus 4 plus 4 plus 4 plus 4 plus 4. So that you've got 6 fours all lined up with addition signs in between. That's what 4 times 6 is representing. So similarly, 4 to the exponent 6, or 4 to the power of 6, is 6 fours, but with multiplication signs in between. So you're multiplying by 4 6 times there, right? So a little bit of terminology. This is what I wanted to put in the last lesson and then forgot. So here it is a little bit more cleanly. So the big number that's, sort of written full size, like all these fours up here, including that 4 right there, that's called the base. And that number tells you what value it is that you're multiplying over and over again. So up here in this 4 to the power 6, it's a bunch of 4s that we're multiplying together. So that's the base. Or more generally, if we wanted to use letters, like how we talked about the use of variables when it doesn't matter what the number is, this a is the base because it's written as like a full-sized large lowercase a. So that's the base. That tells you that you're going to be multiplying a by itself. A times A times A times A. How many times? Well, that's what you're going to get from the exponent. That's the information that the exponent gives you. So it tells you how many times to multiply the base by itself. So in this example here, it's saying that we have our base is 4, so that tells you that we're going to be multiplying a bunch of 4s together, and the exponent is a 6. So that tells you that there's going to be 6 instances of that base with multiplication signs all in between. So if we were to speak more generally, a to the exponent b means that we're going to have a, excuse my writing on the computer, a times a times a times a. I just got to go this way for effect, right? Times a, and it's going to keep going. How many times? Well, in total, you're going to end up with b number of a's, right? Because that's the in the exponent. So if the b was a 10, that means you're going to have 10 a's. If b was 100, that means you're going to have 100 a's, and all with multiplication signs in between. So hopefully that makes sense. And then the entire thing, the whole thing, the base with the exponent attached to it, that whole quantity is called a power. So when you've got a base and an exponent, that's a power. So later on in the practice problems, you're going to see the instructions of the question say, write each of the following as a single power. So that means you're going to be given a few different things that have base and an exponent here, plus base and an exponent here, times base and an exponent over there. And I want you to collect them all and write them as one power, one base, one exponent. That's it. So let's jump into some of the practice before we get into the exponent rules. So here are the practice problems that you can take a stab at. So what you're being asked to do here is solve each of the following problems. So you've been given 5 problems there. You can pause the video, and this is just like the problems that we were doing in the last lesson. You can take a little bit of time to go through these, and you shouldn't really run into any trouble. The only one that might make you think a little bit is D, 8 to the exponent 1. So you can think about what that's going to be. So pause, work through it, and then we will take a look at the answers. All right, so now let's take a look at the answers to these practice questions. So the first one, we've got 6 cubed, 6 to the power 3. So that means you're going to be taking that 6, the base 6, you're going to be multiplying it by itself. How many times? 3 times. So 3 6s all being multiplied together. So 6 times 6 is 36. Times 6, you might need to do some long multiplication to get that 36 times 6 is 216. So that's the answer to the first one. The second one, we've got 2 cubed, or 2 to the power 3. So that's 3 2's being multiplied together. 2's being multiplied together because that's the base. 3 times because that's the exponent. So 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. The next one is 5 to the power 4. So that's going to be 4 5's multiplied together. So that's going to look like this. So we've got the number 5 showing up 4 times, and we're multiplying all those together. 5 times 5 is 25, times 5 is 125, times 5 is 625. Or another way that you could think about this is 5 times 5 over here is 25, 5 times 5 over here is 25, 25 times 25, if you happen to know your square numbers, 25 squared is 625. So that's that. Now here's the tricky one. 8 to the power 1 is just 8. Now why is that? Well, if we think about what the exponents normally tell us, they're telling us how many times we have to write out the base when we're multiplying it by itself, right? So if it was 2 to the power 3, we have to write out the number 3, or sorry, we have to write out the number 2 3 times, right? In 5 to the power 4, we have to write out the number 5 4 times with multiplication signs in between. 8 to the power 1 means you have to write the number 8 once. And that's it. And there's no concept of putting a multiplication sign in between anything because there's only one number. So that's the end of the problem. So anything to the power 1, anything to the exponent 1 is just itself. So 3 to the exponent 1 is 3, 8 to the exponent 1 is 8, a million to the exponent 1 is a million. And the last one, 12 to the power 2, or 12 squared, that's 12 times 12, and that is 144. So hopefully you got all of these right. This one here was a little bit tricky, and the other ones might have required a little bit of long multiplication, but other than that, you should hopefully not have had too much trouble, but let me know in the comments if you did. So now we're going to take a couple minutes to talk about exponent rules. So we'll spend a little bit of time on this slide so that you guys understand what's going on. I know that's a lot of letters over here, but we'll take a few minutes. We'll talk about what these different rules are. And I haven't given them all like their super technical names, but don't worry about the names too much. What I want you to really understand is what's going on over here. And then those words are just there kind of as a reference if you need them. But what you really should write down is this. If you're going to write anything down from this slide, it would be all this math that's going on over here. And what I'm going to do is I'm going to explain what each line is telling you. So in the first line, we've got the product rule. Product is just the answer to a multiplication question. So that's telling you that if you've got two powers, like a to the b and a to the c, a to the exponent b and a to the exponent c, and they're being multiplied together. So you're going to get a product as the answer, because that's the answer to a multiplication question. So a to the power b times a to the power c. What this is telling you is that if the base is the same, now be careful, if the base is the same, it doesn't work for all numbers, but if the two bases are the same, this number here and this number here, if they're exactly the same. If this is 2 to the power 6 times 2 to the power 7, you can do it. But if it's 2 to the power 6 times 3 to the power 7, you can't use this because the bases have to be the same. Now, what this is telling you is that if the bases are the same and you're multiplying the two powers together, then the answer is just going to be you keep that base the exact same and then you add the exponents together. That's what that's telling you. So we're going to explore this a little bit more thoroughly on the next slide when we do the practice questions, but that's what you need to remember here is if the bases are the same and you're multiplying the two powers together, you can add the exponents together. That's what's happening here. Similarly, for the quotient rule, the second one, if the bases are the same and there's a division sign in between, then you can combine them into one power where you subtract the exponents. So you do the first exponent minus the second exponent when you've got a division sign in the middle, and you can do the first exponent plus the second exponent when you've got a multiplication sign in the middle. Be very careful that this only works when the bases are the same. When you've always got the exact same number as your base, that's when you can use this. Otherwise, you cannot use this. All right, so hopefully that makes sense. Hopefully you guys won't forget that. That's definitely a very, very common mistake. And I can tell you right now that when I make a test for algebra or a quiz for exponents or something like that, that's absolutely going to be something that I'm checking for, is whether you remember when you can use these two rules and when you cannot. All right, the next rule is the power rule. So that says that if you've got some number, some base with an exponent, so you've got this power here, a to the exponent b, you've got some power here, and then that whole thing is your base of a bigger power with an exponent c. So basically what we've got is we're saying that a is our base and it's raised to the exponent b, but then this whole thing is a base raised to the exponent c. Right? So that's what we've got going on here. What this is telling you from the power rule is that if you've got a base raised to an exponent and then that whole thing, you put it in brackets and you raise that to an exponent, you can keep the base the same as the original and you multiply the two exponents together. Excuse me. So that's what the power rule is telling you. Now here, there's only one base, so there's nothing about like keeping the bases the same or like making sure that they're the same. You just keep this base the same over here, but you don't have to check anything else in this case to see, oh, is the base the same as that? No, doesn't matter. The next one is similar to this, but instead of having a base raised to an exponent and then that being raised to an exponent, if we had a fraction in here, for instance, and there's more exponent rules that we can talk about later when they come up, but if we have a fraction in here, so a over b as a fraction, and that whole thing is raised to the exponent c, then you can just put that little exponent inside the numerator and inside the denominator so that you can have these two like kind of mini powers inside of your fraction. So that might come in handy at some point. Then there's two very important ones that are a bit less confusing than these two in the middle. The zero exponent rule is any number at all raised to the exponent 0 is equal to 1. Doesn't matter what number it is. Whatever number you have here, if you raise it to the exponent 0, you're going to get an answer of 1. By default, you don't have to do any calculation. If you see something to the exponent 0, say it's equal to 1. That's it. And the last one is the negative exponent rule, which is saying that if you've got some base like a and a negative exponent, so instead of a to the exponent b, it's a to the exponent negative b, what that's telling you is take this a, so basically this is a like over 1, right? And what it's telling you is this minus sign is saying, hey, I know you're in the numerator right now, but if you don't like the minus sign in the exponent, you can chuck me in the denominator and then you don't have to worry about the minus sign anymore. So that's what the negative exponent rule is telling you, that if you've got a negative exponent for your base, you can flip that whole thing over, so you can make it the denominator with a numerator of 1, and you can get rid of the minus sign in your exponent. Similarly, if you had, for instance, if you had 1 over a to the negative b, if you had something like this, then you could flip this whole thing over so that the a comes upstairs, and you get rid of the minus sign. So those are some helpful rules. You're not going to need all of them in the practice problems coming up on the next slide, but they're good rules to know. So write these down. Hopefully you understand them. If you don't understand them, talk to me. All right, leave me something in the comments. Talk to one of your other teachers to get in touch with me. Talk to one of your other teachers for help. Just, don't sit there and like stress out. I know there's a lot of letters on this slide. I know, but I want to make sure that you understand this, and it is hard for me to know whether you guys are getting it or not because I can't see your faces when I'm giving this explanation. So please, please, please let me know if you're struggling, and I will absolutely try and explain it in a different way to make sure that you guys understand before we move on too far. So that's it for the exponent rules for now. There's definitely more exponent rules that we can check out later on, but these are the ones that I wanted to cover right now. So let's get into some practice problems. So here are some practice questions involving exponent rules. So here you can see I've said write each of the following as a single power. So I don't want you to solve it. I don't want you to do 4 times 4 times 4 times 4 times 4. I want you to tell me here we've got the same base. We've got a 4 here. We've got a 4 here. So we can use one of the rules from the previous slide. I want you to figure out how can I write this as one power? 4 as the base and something as the exponent. What is that something? That's what you're being asked to do here. You're not being asked to do 4 times 4 times 4 times 4 times 4 and figure out how many 4s you need and do all of that multiplication. That's not what we're doing here. We're just trying to use those rules from the last slide so that we can take these things that are 2 powers, or maybe like a special kind of a power where they're written like, in a kind of weird way. They've got weird exponents, they've got weird stuff going on, and we want to simplify them down using the rules from the previous slide. So I'll give you guys a few minutes. You can hit the pause button here, and then we will check out the answers. All right, so let's take a look at the answers to these practice questions. So the first one is following the product rule, the first rule from the last slide. The base stays the same because we got a 4 here, we got a 4 here, so we'll keep the base the same. And because they're being multiplied together, the product rule says that you can add the exponents together. So we get 4 to the exponent of 3 plus 5, which is 8. So 4 to the exponent 8. The second one follows the quotient rule. So we've got 2 to the exponent 10 divided by 2 to the exponent 3. So because the bases are the same, we just keep them the same. So 2, 2, 2, no problems. And the quotient rule says that if you've got this division sign in between 2 powers with the same base, then you can subtract the second exponent from the first. So it'll be 10 minus 3 as the exponent, which is 7. So you get 2 to the exponent 7. The third one, it's technically already written as a single power, but that single power is, it's got an exponent of 0, and we know that having an exponent of 0 means that it doesn't matter what your base is, the answer is going to be 1. The fourth one is following the power rule from the previous slide. So if you've got a base to an exponent, and then that whole thing is a base raised to an exponent, then that tells you that you can multiply the exponents together. So the base was 13, so the base stays 13. So we have 13 to the power of 4 to the power of 5. So when we have this kind of a setup where we've got base, exponent, and then another exponent on the outside, we can multiply those exponents together. So we get 13 to the exponent of 4 times 5, which is 20. So 13 to the exponent 20. And the last one is 16 to the exponent negative 4, which again is written as a single power, but because it's got a negative sign, we can flip that whole thing on its head. So we put that 16 as a denominator in a fraction with an exponent of, or in a fraction with a numerator of 1, and the exponent in the denominator loses the minus sign. So it goes from 16 to the exponent negative 4 over there to going downstairs to the denominator, but without the negative sign. So it's 16 to the exponent 4. So hopefully that makes sense. I hope, you know, that there isn't too much trouble, too much confusion here because you just went over the exponent rules on the last slide. Now, I do understand they're new, definitely, for some of you to see those rules and to see that many letters. So it, you know, I know it takes a little while to get used to it. Let me know how you guys are finding this. Hopefully you guys picked a class rep from a couple days ago. So if you're finding that most of the class is struggling, get your class rep to let one of the other teachers know or to get in touch with me directly. So that's it for this slide. And here are the last couple of things that we're going to do in this video. We're going to do a little bit of practice involving BEDMAS. So we're going to use a little bit the exponent rules that we saw in the last couple of slides, but we've also thrown in a bunch of other things going on now. We've thrown in addition and subtraction, and we've got to keep track of like our BEDMAS rules and stuff. So basically what you need to remember is BEDMAS is telling you that you have to solve anything with brackets first. Now, before you pause, I'm going to tell you something that down here in the second problem, if you look at the exponents first, it'll make your life a little bit easier. You don't have to do as much calculation as it looks like, but you have to only do, you can only break this BEDMAS rule if you've got exponents that are really friendly, exponents like 1 and 0. Pretty much any other exponent, you should probably solve things on the inside first. But anyway, I'm getting a little bit ahead of myself. So in this first example, you don't have any brackets. You do have a whole bunch of exponents. But what we're going to do is we're going to make use of our exponent rules to make it a little bit easier. You see here we've got two bases that are the same, and they've got a division sign in between them. So you can use the exponent rules that we just talked about to save yourself a little bit of trouble instead of hashing out all of this math and then all of this math and then doing the division, and that's a lot of stuff. So instead of that, try using the exponent rules here. I'll even put it on the screen. Try using your exponent rules here, here, and take note of that exponent right there and what that means. So those are your hints, because I know it's a little bit, we're doing a lot of like new stuff in this video. So I'm giving you a couple of hints. And now you can pause the video, take a few minutes, and work through these problems. All right, so let's dive into the solution. So here's the solution for the first one. Let's take it line by line. So using our exponent rules, we can use the quotient rule here to get that the base, if we keep that base as a 3, because it was a 3 in both of those cases, because we've got a division sign, we can actually subtract the second exponent from the first one. So this middle bit here of 3 to the exponent 5 divided by 3 to the exponent 3, we can write that as a single power of 3 to the exponent 2, because it's 5 minus 3 is the exponent. So that's where we get this 3 to the exponent 2 right here. Now, following BEDMAS, we don't have any brackets, so we'll figure out what all of these exponents actually evaluate to. So 2 to the exponent 4, that's 2 multiplied by itself 4 times. So that's what we've got here. Plus 3 to the exponent 2, so that's 3 times 3. 3 shows up twice. Minus 4 to the exponent 2, so that's 4 times 4. Just 4 is showing up twice with a minus sign. Then we deal with division and multiplication first. We don't have any division, but we do have a ton of multiplication. So doing this multiplication, we've got 2 times 2 is 4, times 2 is 8, times 2 is 16. So we've got a 16 here. Then we skip the plus sign because we're still on multiplication. 3 times 3 is 9, so that goes here. Then we skip the minus sign. 4 times 4 is 16, so that goes here. And now we're left with just addition and subtraction. and you'll see that we've got a 16 here and a minus 16 there. So you do this calculation, you'll get an answer of 9. Now for the second one, we've got, so with this first one, the only thing that you really needed to note at the very beginning is that from a few examples ago, raising anything to the exponent of 1 doesn't change it, right? We had that example that was 8 to the exponent 1 equals 8. So we don't need to have this in brackets. We don't need to have the 1 out there. So I got rid of that over here. But I didn't touch the stuff that was on the inside. I just got rid of basically I just realized that, oh, if we've got an exponent of 1, that's not changing anything. So I don't need to write that 1 on the outside, and I don't need to write these brackets here. So that's basically all that I got rid of going from here to here. But then this thing over here, 18 squared minus 15 squared to the exponent 0. What we need to remember is that anything raised to the exponent 0 is equal to 1. So this whole monster right here, because of that exponent 0 right there, is equal to 1. And so that's how we get this 1 right here. So the minus sign still carries over. This minus sign right here is this minus sign right here. This thing used to be the thing that was in brackets with an exponent of 1 on the outside, but then we got rid of that because the exponent of 1 doesn't change anything. And that's it. So that's our first step, is we've got rid of that exponent there, and this whole monstrosity right here with all these huge numbers is just a 1. Now we can use our exponent rules. 2 to the exponent 10 divided by 2 to the exponent 8. We've got the same base, different exponents, and a division sign, which means we can subtract the two exponents. We can subtract the second exponent from the first one. So we get 2 to the exponent of 10 minus 8, which is 2. So 2 to the exponent 2, or 2 squared, minus 1. We just don't touch the minus 1 yet. So now we've made use of the exponent rules. Now we have to actually solve the exponent, which is 2 to the exponent 2. That's the same thing as 2 times 2. I didn't write that out here because of lack of space, but 2 to the exponent 2 is just 2 times 2. So we could have this intermediate line that says 2 times 2 minus 1. And then before we do the subtraction, we have to do the multiplication following BEDMAS. So we get 2 times 2 is 4, minus 1. 4 minus 1 is 3. So hopefully now with that, you're seeing some of the utility to exponents, that they can simplify some of the problems a little bit when you've got situations like this and like this, that instead of having to calculate 2 to the exponent 10 and then calculate 2 to the exponent 8 and then do this division between two massive numbers, you can get rid of all of that and you're left with 2 squared. 2 times 2 equals 4. That's it. Saves you a lot of trouble. Same thing over here. Instead of doing 18 squared, which is 18 times 18, and figuring that out, and then 15 squared, and that's 15 times 15, and then doing the big subtraction, we just noticed that we've got an exponent of 0, which means that it's equal to 1. So I just wanted to show you guys some of the utility of exponents, exponent rules, and things like that. I understand it's going to take a little bit of time to get used to working with them, but hopefully now you're feeling a little bit more comfortable than yesterday, at least with the stuff that we talked about yesterday, or not yesterday, a couple of days ago. And I know it'll take a little bit of time to really get settled with all of this, so please watch this video again if you have to on your own time. I know nobody wants to, but it's only going to be about half an hour of your time. So if you need to watch this video again, please do so. If you need to watch a different video, if you need to come to me for help, if you need to go to one of your other teachers for help, please do. We're all happy to help. And yeah, I hope this lesson makes sense for you guys. And that's it for today. We're not doing any more practice today. So with that, I will leave you for the weekend, I guess. I'm recording this a day earlier than I usually do, so it feels weird to say like, oh, happy weekend, because when I'm recording this, it's Tuesday. But yeah, that's it for this lesson. I will try to check in to see how you guys are doing. And that's it for this video. So I will see you all in the next lesson. Have a good one.